So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says maximum XOR subarray of size k. It is very similar to maximum sum subarray of size k, which we have already previously done. If you are unaware, you can click the video over here and see that. But yeah, here is the XOR, and which says given an array of integers ARR and a number k, return the maximum XOR of a subarray of size k. And subarray is a contiguous part of any given array. So we are given an array. Now this can be a subarray, this can be a subarray, this and so on. But the maximum subarray of size 3 is this one. That is what 15. So the XOR of all these elements, 3 elements are 15. XOR of these 2 elements are here, which is 6. And they expect us to solve this with an O of n time complexity and O of 1 space complexity. Now in a brute force solution, you can go ahead and just run 2 loops, which would give you O of n square solution. So brute force solution would be like O of n square time complexity, but that's not a very efficient solution. Although the space complexity is O of 1, but yeah, time complexity is a bottleneck here. How can we optimize this? So here we can do one thing, that hey, the idea here is to understand what they're asking. They're asking of array of size k, and then they ask us for maximum. Now size k follows k elements from 0 to k minus 1, obviously, and then the next subarray would be 1 to k, and then the next subarray, both inclusive by the way, next subarray would be k to 2 to k plus 1, so on and so forth. Likewise, you see every time what we are having start plus 1, then end plus 1. That means we remove the last from the previous window and we add the new incoming to current window. So with this logic we go ahead, and that is very essential to understand. This kind of pattern is known as sliding window, where we keep our window rolling, we adjust the window as per the movement. So the movement is from left to right. That means I am removing left and I am adding right. So what does removing and adding mean in terms of XOR? We will see that. So with that thing in our mind, that we wanted to add and remove the left and add the right, and hence we slide it. And while sliding our window, we would keep track for the maximum one. So we would keep track of the maximum. That means we need a variable known as maximum, which initially I'll assign to 0. And for current, we'll use a current CUR. CUR is the running XOR. As we go ahead, we need at least k elements with us. You see, the first window we have is 0 to k minus 1. So what I'll have is, I'll iterate int I is equal to 0, I is less than k, and I plus plus. The first window I'll say. So for the first window we are running this loop, and it will have XOR of all the elements within that window. So A of I. When the loop ends, we are sure we have covered the first window. Next what? We need to run again, but this time from, what is this starting of next window? It is, okay, we have 0 to k. Now we wanted to go from k to the next. So we have iterated from 0 to k exclusive here. So I'll add k here and I'll have int I is equal to a dot length I plus plus. So what I'll do is, instead of I, I'll take a end and end, and start would be 1. What is this start and what is this end? It is the next window. We already had 0 to k minus 1 as first window, where this was start and this was end. Now we are having, first window is done, by the way, done. Now for second window, this is start and this is end. That's what I have done. Start is 1, end is k. That is what you will see here. Start is 1, end is k. I'll take start as integer. Now with that thing in our mind, we wanted to roll the hash. We wanted to roll our sliding window or slide it. What does sliding means? It would go from left to right, right? And I am removing the left and I am adding the right. So let's remove the left. So first of all, let me compare the maximum value. Maybe the current value which we are having right now is the maximum. So let me compare it first. Mat.max, max with current value. And once you are done, slide the window. You know the how to slide the window? That means remove left. How would you remove the left? So you would remove the left by having current X0R is equal to a of start minus 1. So this was start one. I wanted to remove the previous one because we have completed the window. The window here is start to end, and that's what I want. And current X0R equals to a of end. Don't get misleaded. This one here is for removal and this one here is for addition. Since this is an XOR operation where removal and addition both happens with the XOR sign, so if you have a number, you XOR with that first time, you're adding that. Next time, if you're doing again the XOR, you're removing that number. That is how XOR works. Now we have slided the window. What should we do? We should take start plus plus and also end plus plus. But wait a second, end plus plus is already happening over here. So either I should remove this one and write it here end plus plus. That would work. Ultimately, what I'll do here is I'll return mat.max of the maximum which we found or the current one. So let's compile this one. The last max condition I have written because maybe in the end subarray might contain the maximum number. In that case, we wanted to consider the end subarray which will store the value in cur, and max is the maximum so far. Let's submit this for rest of the test cases. And yes, it solves all the test cases is solved here. And this was a classic problem regarding arrays and sliding window. It also uses bit magic. Bit magic comes into picture of having XOR. We didn't have any branching, else we could even go ahead and optimize the solution. But yeah, so time complexities and space complexities are respected, and here is the complete solution. For more such content, click the video on your right, and I'll see you in the next one.